Hello, in this video I am going to solve a problem for you on the topic of trigonometry. Of course, I cannot categorize it under a specific title in trigonometry. We can consider it a miscellaneous problem in trigonometry. Let us read the problem together first. Let x be a trigonometric angle such that a sine x squared minus b times cosine x squared is equal to a minus b for some real numbers a and b. What is b sine x to the power of 4 plus a times cosine x to the power of 4 in terms of a and b? That would be a good idea if you pause the video at this point and try to solve the problem yourself first. If you solve the problem correctly, the answer that you will get will be AB over A plus B. Okay, now let us go to the board and try to solve the problem together. So, I know that a sine x squared minus b cosine x squared is a minus b for some a values a, b, and x. We want to find an expression for this question mark in terms of only a and b. In other words, I want to get rid of the x variable in this question mark. Okay, so what can I do? Because I want to get rid of x, so it might be a good idea if I go back to this assumption and try to find sine x and cosine x in terms of a and b. Because if I manage to do that, then I can put those expressions expressing sine and cosine in terms of a and b in this expression, then at least what I get is something which is independent of x. Okay? So, let us start doing this project. So from here, I have sine x squared and I have cosine x squared. I use this famous identity that I have, sine x squared plus cosine x squared equals to 1. This is the famous trigonometric identity. So, for example, from here, I can realize that cosine x squared is equal to 1. I move this to the other side, which becomes minus sine x squared. Or, of course, if you want, you can write sine x squared here is equal, move cosine to the other side, which gives me 1 minus cosine x squared. So, here, for example, I want to actually use both of them because I need both of them, sine and cosine. So I go here, I copy and paste the first term as it is, but instead of cosine x squared here, I can use this formula. So then becomes minus b, 1 minus sine x squared is equal to a minus b. Okay, and then now you see that I do not have any mixture of sine and cosine, everything is sine x here. So I do some simple algebra, meaning that I expand this, multiply minus b in plus b sine x squared is equal to a minus b. Then this minus b that you see here, I move it to the other side, it becomes positive b, and this will be cancelled. Between these two terms, I can factor a sine x squared out. I put this out, so a is left, plus I took this out, b is left. On the right hand side, I have a. Okay, this should have been mentioned in the problem itself that a plus b is not 0, because I want to make sine x alone. Assuming that this is given, might be that's a little flaw in the problem. So sine x squared is equal to a over a plus b. This is what I get. So this is good because it expresses sine x in terms of a and b. And I can use this formula, for example, to find cosine x in terms of a and b. How? I would say that, okay, cosine x squared is 1 minus sine x squared. But I just got what is sine x squared, so I replace it here. Yes, so this becomes minus sine x squared. This becomes 1 minus. Instead of sine x squared, I write a over a plus b. And then I want to take the common denominator, so I would write, instead of 1, I write a plus b over a plus b to make the denominators the same. And then this gives me a plus b as the denominator. And then I have to subtract these two. A plus b minus a, a's are cancelled, so b is left. So let me write it in that way. So this means that cosine x squared is this expression. Okay, now let us go back to the question mark. Question mark is this combination, but sine x to the fourth, cosine x to the fourth, but this is very easy to calculate now. So I would write that the question mark is my b here, multiplied by sine x to the power of 4. But sine x to the power of 4 means sine x to power 2, once more to power 2, yes? And the same story for cosine to the power of 4. So I can write it like this. Okay, but now I know what is sine x squared is. This is this guy. And I know what cosine x squared is. That one. So what can I do? I would say that b, instead of sine x squared, I just write a over a plus b. What I have written is just for this part, and then I have another power of 2 top there, and then plus a, and then instead of that expression I write b over a plus b, but I have another power of 2 there. But then I have a fraction raised to a power, so this means that I have to raise the numerator to that power and then the denominator to that power. Okay, the same thing happens here. So I copy and paste the a part, I raise it to power 2, so it becomes b squared a plus b squared. Okay, but b is being multiplied by a fraction, so if I multiply, I give a denominator 1 here, b will be multiplied in the numerator, so it becomes ba squared, so I prefer to write a squared b. It doesn't matter, of course. And then you have a plus b squared. Plus, the same thing here, a times b squared divided by a plus b to the power of 2. But then, fortunately, the denominators are the same. So what I do, I write the same denominator, and then I add the numerators, yes? But then you immediately realize that between these two terms, I can factor an AB out. So then it becomes AB, from here A is left, plus from here only B is left. And then divided by a plus b squared. And now this a plus b and one of these a plus b's are gone. So from the numerator, I have ab left, and in the denominator, I have a plus b. So this means that this question mark is indeed equal to this expression. So using this trick, I was able to actually write this question mark only in terms of a and b, if, of course, this condition is met. I hope that you enjoyed the video. Until the next video, be safe and goodbye. Thank you.